Hi everyone. In this video, we will learn about the Gibbs free energy. We have learned about entropy, and the entropy can be calculated through the entropy of system and entropy of the surrounding. So once again, the total entropy change will be equals as the delta S system add with delta S surrounding. Okay, you already know as well that the delta S surrounding could be calculated by the change, the negative change of delta S system over T. Okay, so this is the formula that we have learned. So if you multiply this equation by negative T, okay, then this will change to negative T delta S total equals to negative T delta S system plus delta S system. Okay, the negative T times delta S total will be gives a new function known as Gibbs free energy. So the delta G system is equals to delta H system minus T delta S system. So this is the formula of how we find the Gibbs free energy. Okay. So once again, the Gibbs free energy system will be equals as the delta S system minus T delta S system. Yeah, you can see that in spontaneous reaction, that the value of delta G will be negative. Yeah, will be less than 0. This is the rules for spontaneity. Once again, if you want a spontaneous reaction, then the value of delta G should be negative. Okay, what is the standard conditions? You can see the symbol. Yeah, this is a symbol for standard condition. So what is standard conditions? The pressure should be in 10 to the power 5 Pascal. The temperature 298 Kelvin or 25 degrees Celsius. And its substance involved in the reaction in its normal physical state at this pressure and this condition. Okay, to find about the delta G system, we can also find from the delta G formation, delta GF. Okay, the units are same as the delta H, so this is kilojoules per mole. So delta G formation is the delta G that gives free energy change when 1 mole of compound form from its elements under standard conditions. So the definition is quite same as the delta HF or delta H formation. Yeah, but in this case is the Gibbs free energy change when 1 mole of compound formed from its elements under standard conditions. So now let's see about this question. The zinc carbonate decomposed to form zinc oxide and carbon dioxide. The delta H reaction for this is positive 71, and the values of entropy for each substances could be this, and this. Now please calculate the Gibbs free energy change at this condition. Okay, you already know the formula that the delta G equals to delta H minus T delta S. So what we should do is change the unit. Yeah, for the delta S ration, we can change the unit to joules. So 70 times 10 to the power of 3 joules per mole minus T. T is 298 times delta S. Okay, we should find the delta S. Product minus reactant. So the product is zinc oxide plus carbon dioxide minus 82.4. Okay, so the entropy change of the system is 174.8. Okay, this is in joules per Kelvin mole. This is Kelvin. So the result is positive. Joules mole minus 1. You can change it to kilojoules. So you can see that the sign is positive. So this is a not spontaneous reaction. Yeah, since the value of delta G is positive. Okay, now let's see once again this question. For entropy, I forget that there is not in your data booklet, but actually appear in every question. Yeah, for the entropy change. So now I'd like to give you information about the entropy. Yeah, to answer E. This is in joules. Yeah, joules per Kelvin mole. Okay, please pause the video and try to answer this. Okay, now let's discuss the answer. Give an equation for the boiling of water. So this should be S2O liquid to S2O gas. Predict a sign for the enthalpy change and entropy change for this process. Enthalpy change would be positive. Why? Because we need to break the hydrogen bonds inside the liquid H2O to change it to the gaseous state. Yeah. Once again, this is positive due to it is an endothermic reaction. Yeah, breaking the intermolecular forces with its hydrogen bond. How about the entropy change? The entropy change also positive. Yeah, because from liquid to gas, more disorder. Yeah, so the entropy change would be positive. Predict a value for the sign of delta G at low temperature and at high temperature. You know that delta G is delta H minus T times delta S. Okay, suppose you have a low temperature. Okay, a low temperature, so the T delta S is negative but small in value. So the delta G with the positive sign of delta H and a small negative value of T delta S, the delta G will be positive. This is occur at low temperature. But high temperature, at high temperature, T delta S value will be large in negative value. Okay, so delta G is positive minus T delta S, and this is negative in large value, in large number. So the delta G will be negative at high temperature. Okay, D. Suggest why water boils at 100 degrees. Don't say that you just memorized this, right? Okay, but suggest why water boils at 100 degrees. Yeah, you can see through C. Okay. Water only changes to the gaseous state at high temperature since the value of delta G is negative at high temperature. I repeat once again, why water boils at 100 degrees Celsius? Because the change only occurs at high temperature where the delta G is negative. Okay, E. Use the entropy value to calculate the entropy change for this process. I already give you this. So delta S is product minus reactant, which is 188 minus 70, which is 118. Yeah. Okay, the entropy increases, has a positive value. Okay, now let's see F. Use the data below to calculate enthalpy change for the process. Product minus reactant, so positive 44 kilojoules per mole. Deduce the boiling point of water from your calculation. So that means this is not 100, yeah? Describe any assumptions that you have made. Okay, as we know that at the boiling point, delta G equals to 0. Okay, at boiling point, delta G equals to 0. So delta G equals to delta H minus T delta S, and this is 0. So T delta S equals to delta H. Delta S equals to delta H over T. Now we can use the result form F, which is 44 kilojoules per mole. Oh, sorry, we want to find T, right? So I convert this. I change this, T equals to delta H over delta S. So 44 kilojoules per mole over delta S, which is this. This is in joules, 118. So we should convert this to kilojoules times 10 to the power of negative 3 kilojoules per Kelvin mole. Okay, use a calculator. $370 Kelvin. So we assume that the boiling point of water from our calculation is occur at 370 Kelvin. Assumptions that we made. It is assumed that delta H and delta S do not change with temperature. Yeah, we assume this and this do not change in temperature. So that's why we can find the boiling point. Okay, I hope you already understand about the Gibbs free energy calculation.